Hi. So this video is going to be discussing a new function that we haven't seen yet, which is linspace, which stands for linear spacing. And it involves making a list of numbers. And we've seen this before. When we think back to our earlier notes, we know that we can make a list of numbers using the colon operator. Let's say do 0, 2 to 10. Or what we've done is we set a starting number, an increment, and an ending number. So based on that idea, we'll start at 0. We'll increment by 2s until we get to the ending number. So if we run this, we see that we start at 0, we end at 10 with a known increment of 2. Now, the big thing here is that we know the increment. We don't know the number of points. And sure, you can go ahead and for something simple like this, you can figure it out. You could run the code and then do something like length of x to tell you that there's 6 elements there. Or you do size of x, where the major difference there is that size of x will tell you the dimensions of the matrix. So that's 1 row by 6 columns. Of course, we can do that. Now, it gets more complicated if you have a list that starts at, let's say, 12. It goes up in increments of 17, and it'll keep going until 3,481. Now, one thing about the colon operator is that depending on the number you have at the end, it will hit that number or it'll stop incrementing before going over that number. So in this case, we know this list will still be 0, 2, 4, 6, 8, 10, because this 11 here is just saying what the maximum number is. So end is really the max possible number. That's what this guy is. It's the max possible number. So if I do 0.25, let's say, you get a lot of points that ends at 11. But I would do 11.15. If you look, 11 is the final number in the original list. If I increment by 0.25, I go over this number. So we will not have that number in our final list, as you can see here. I just ran it again, and it's still at 11. But then if I go to something higher than 0.25, now we see it pops up. Now, the reason I bring this up is because if you look at this x2 list, I have no idea if it's going to end at 3481. Maybe I got lucky. I kind of doubt it. Let's look at what x2 is. 3480. That's pretty close. We see there's 205 elements. I think it'd be very difficult to predict that just looking at this. But that's what this code does, is that every increment will be by 17. We can see this here. We're adding 17 continuously. And that's what the colon operator does. Now, the difference between the colon operator and linspace, let me copy and paste this. But for linspace, we do not, or we don't know the increment, but we do know the number of points. Now the increment, I can't spell, the increment will be the same in between numbers, but we don't specify what that increment is. So in this case, we specified it was 17. That was from including this here. In this situation, we cannot specify what the increment is. So let's look at the formatting of linspace. The command is linspace. We will specify our starting number. We will specify our ending number. And then we'll specify how many points we want in between, where those points will be set up in a linear fashion, where we increment by the same amount each time. Let's look at an example. And this n here is the number of points in the list. If I were to say, let's make a list that goes from 1 to 8, and I have 2 numbers, well, the fact that there's 2 numbers, let's go ahead and write out what we think this is. Starting is the number 1, ending is the number 8, and we need 2 numbers. Well, those are our 2 numbers. The list is complete. If I run this, we'll see that we just get 1, 8. Now, let's make it a little bit more complicated. just to see if we understand. In this situation, we have our starting number is 0. Our ending number is 1, but I need 3 points. So I need some number in between that is equidistant from the 0 and the 1. And just from observation, we should be able to figure out that this has to be 0.5, because this point is 0.5 away from 0 and 0.5 away from 1. It's equally spaced. So if I run that, we see that we end up with those 3 values, because again, we selected our starting value, we chose our ending value, and the number of points will dictate ultimately what we want that increment to be. Note, I do not have any 0.5 in this. MATLAB will determine that for you automatically. Do another example. Let's say we do linspace 0, 1, and 4. So again, our 0 and our 1 are going to be the starting and the ending numbers. That's 2 numbers in our list. So now we need to think of 2 numbers that go in between here. Oops. Well, maybe your first thought is, let's do a wrong answer. Let's say I do 0.4, 0.8. We see that the 0.4 is exactly 0.4 away from this number. 0.8 and 0.4 are separated by a distance of 0.4. But 0.8 is 0.2 away from 1. That can't be possible, because the distance in between every point has to be the same. So if you think about fractions or you think about decimals a little bit more, we'll see that we have to increment in increments of a third. So let's say we do 0.333, 0.666, etc. Basically 1/3, 2/3, and 3/3 is 1. We see that every single point is separated by this amount. So if I were to run this, we see that we end up with this. I note this 7 is here because it's rounding for us. It's only showing 4 digits. But that is what is happening there in that situation. Let's do some more examples. Let's say we go from 10 to 20 with 6 numbers. So 10 and 20 as our starting and our ending numbers. Now we want to include 4 more numbers that are equally spaced apart in here. And take a second to pause it if you want to think about it. And I'm assuming now that you're done pausing, we would end up getting an answer that's 0, 12, or sorry, 10, 12, 14, 16, 18. We just added 4 more numbers, and they are all 2 apart. That is our linear spacing. So if we run that, we see that we end up with that exact answer that we expected. Now let's talk about some cases where you might not type something. So if I do linspace, let's say 1 to 100, and I don't specify the number of points, MATLAB defaults to 100 points automatically. So it will go ahead and create 100 points in our list, with 1 and 100 in this case being the starting and the ending number, with 98 numbers in between. I hope it's self-explanatory to figure out what the difference is, because if I'm going from 1 to 100 with 100 points, that increment has to be 1. So first, let's run this. And if I do length of x, you'll see that it's 100 points. That's the default. And if I do x, we'll see that it increments from 1 to 100 in increments of 1. Let's show this with another type of thing. Let's go. I go from 2 to 4. Again, 100 points is default. So let's clear this. Let's go ahead and run this. And let's do length of x. You see that the length of x is automatically 100. That is the default by MATLAB. And now if I look at x, you'll see that it's incrementing by some random thing. And it's continuously doing that between each points. If you want to know what the increment is, you could just take the difference between 2 of those points. And if you do that, we see that our increment is whatever that is, 0.0202. And you can do that between any points. Let's say I do 87 and 86. Doesn't matter. I get the same exact answer, because it's linearly spaced. Every single space is exactly the same value. I think that's all I want to talk about in this video. If you have questions about linspace or the colon operator, please let me know. Go ahead and comment or message me on Teams, and we'll discuss it further. But I hope this was helpful. If you have any questions, again, please feel free to reach out. Okay. Happy coding. Have fun. Bye.